This is an experiment set up. The robot first acquires its internal model, the predictor, by executing action by himself. And then once acquired the predictor, robots first try to estimate what is their next actions of the human's action. In this case, the person tries to push the blue car, but then as the blue car is too far for him, so he could not achieve the goal. But then the robot watching these actions, and as the robot already acquired their motor abilities to push the car, robot can expect what is the outcome of this human hand movement. And then if the humans could not achieve the goal, the prediction error is measured. This prediction error execute or activate their execution of their predicted actions like this. So here is the experimental setup. First, the robot explores the environment by himself. Robot learns to push the blue car and also learns to cover the red marker. Here is the camera view of the robot. For the sake of simplicity, we just use the color information to recognize the object state. And then once the robot acquires its own predictor or forward model, it can apply it to estimate the outcomes of the human behaviors. Here, my students try to cover the red marker, but then as the red marker was too far for him, he could not achieve it. And at this point, this prediction error becomes larger. This elicits the robot action execution. And next example is pushing the blue car. Again, the blue car was too far for the student, so he could not achieve it. And then the robot, while observing the human's trial, the robot first detects the prediction error, and then this prediction error activates the action of the robot or movement. Here the point is that in this case or in this theory, the robot does not have an intention to help others, but robot just tries to minimize prediction error. So the robot does not differentiate self from others, but then always try to predict what the outcome of the current state, what is the next state, and so on. And then if there is a prediction error is detected, robot always tries to minimize the prediction error. And then as a result, this behavior is recognized as our artistic behavior. We suggest that this is the very beginning of their artistic behavior, the development of artistic behaviors. Okay. So then I showed you the two examples of the robot experiment, and then I'd like to now extend our theory to understand the underlying mechanism of autism spectrum disorder. I think you know the autism spectrum disorders. They are characterized by the social deficit, like difficulties in making eye contact or difficulties in understanding other person's intentions. And in contrast to these traditional theories, recent studies focuses on their atypical perception, like a very high contrast, hypersensitivity, or hypoesthesia, or local processing bias, and so on. Let me give you examples. First, left side, you can see the two pictures. One is the original image, which captures the red colored leaves in the maybe Japanese autumn. And the bottom, you can see the same image, but the highly contrasted image. And my colleagues who are working in University of Tokyo, who suffers from autism spectrum disorder, suggest that she sees this kind of highly contrasted images in their daily life, in his daily life. And another example of atypical perception is shown on the right side. At the top, you can see the hierarchically compound letters. Here, there are small h and large s. The question is, which letter, larger letter or smaller letters, comes into your mind first? May I ask you a question? if you think that the larger letter is more prominent or more salient for you, or smaller letter, could you raise your hand? Larger letter? Smaller letter? Thank you. These studies have shown that the typically developed persons tend to first detect the larger letter, and then smaller letters is detected later. ASD, autism spectrum disorders, tend to first detect the smaller letter and then larger letter. This is the result that they found. But please don't worry about your result. It depends on how close you are sitting in the screen, and also depends on the developmental condition, the experimental conditions. And so these are the behavioral knowledges we are knowing about our ASD. And we suggest that this behavior, atypical behaviors, can be explained by the atypical tolerance for the prediction errors. Here I draw a very simple example. Imagine that these dots are showing their sensory motor information from the environment. And in the case of typically developed persons, we try to understand this sensory motor information by applying the models which alert certain level of prediction error or tolerance. When we receive their sensory signals, we do not exactly try to explain each signals, but roughly explain the model. For example, in this case, I applied a linear regression model, but then you can see that some tolerances are accepted in this model. And in the case of ASD, the researchers suggest that the ASD people may apply very low tolerance or very large tolerance, like this one. Note that the dots, their sensory motor signals, are exactly the same between the left and the right one, but just the tolerance of the models are different. And now you can imagine that the internal model of the typically developed persons and their ASDs are so quite different from each other. So this theory suggests that their communication difficulties happens not in ASD, but between TD and ASD. Because of the difference in the internal model, we cannot easily communicate to each other. This is not just a deficit in their ASD side, but the deficit between TD and ASD. So this theory, our theory, is suggesting that the prediction error, their atypical prediction error, may explain the underlying mechanism of their social deficit in ASD. Yes?
So that suggests to me that at least in the hyperesthesia case, as the person has more and more data, they should eventually relax towards the typical development model, because essentially their very detailed model will overfit the data and they'll have even more error. So as they accumulate more data, they'll experience more error until they actually fall onto the left-hand curve. Is that actually consistent, or does it not turn out that way?
So I could not clearly understand your point. Could you
well, if I were training a machine learning algorithm, yes. For instance, and I saw the behavior on the right.
It's like an overfitting in the
Yeah, so if I add more data, then eventually that overfitting behavior will tend to disappear, assuming I keep everything else constant. Because essentially I won't be able to fit the little peaks and valleys, since I'll have counterexamples and things like that. And eventually it smooths itself out. Does that actually happen in real cases?
Why do you think that it's smoothed due to the more data?
Because if I add more data, then
you mean the data in the mean level?
Well, some of that is noise, right? And overfitting is when you fit the noise rather than fitting the signal.
Yes.
So when you resample the noise, you get a different answer. So you regress towards the mean.
Okay.
The question is whether you can consider noise as noise, right?
Right.
So if you believe that the world is deterministic, you keep overfitting for the new data.
So what happens in the actual in actual people?
There are two types of people. One type has a very low tolerance. The other type has a very larger tolerance, although the top is the more dominant. And then this is, as this is still an hypothesis, theoretical model, we cannot really verify that whether they really have this kind of model or not. Some behaviors, the characteristics can be explained by this kind of their tolerance or the atypical prediction learning. But unfortunately, we cannot exactly match this idea with their behavioral, their findings in the ASD. But we try to,
These two kinds of tolerance, typical tolerance, can these two kinds be considered as same class?
You mean this one and
This one and this one?
I don't think so. But there are some people say that depends on their conditions of the ASD. Some day they have very, very low tolerance, but another day the same person has very large tolerance. It's a kind of there are two sides of the same coin. So depends on their conditions or environmental state, they can easily switch between these two.
It may suggest that the notion of ASD is so coarse or not so much suitable for explanation of such kind. Because if we naturally these three kinds of tolerance, then we put the so-called typically typically matched person as a center.
Yep.
So it's not so much
So
natural.
ASD are kind of called a spectrum disorder. So
Yeah.
it's,
Of course.
and also there are some subtypes like Kana type or Asperger type.
Many
So
kinds,
so it is not the
Yes, but
more disputed,
to put something in the line, one line is, I think it has a difficulty, more partially ordered, like the original picture of tree.
Yeah, as you mentioned that we think that the TD is a kind of middle, and then there are ASD, two types of ASD are there two edges of this one line. Because so you can say that this is a very low, smaller tolerance, which causes the hypersensitivity, and which this one is the hypoesthesia. And we actually designed a neural network model which produces these three phenomena just in one model, by modifying their excitation and inhibition imbalance, but the balance in the neural network. There are several neuroscience studies showing that the ASD has atypical balance in their visual cortex or prefrontal cortex and so on. And then our computational model showed that by modifying the EI balance, if we have the very high EI balance or very low EI balance, we can generate this one. And if we put the very proper EI balance, which are produced through the generation, the learning process, we can reproduce the TD-like behaviors. So our suggestion or our hypothesis is that the ASD and TD are in the same line. Just by modifying their EI balance or some modulations in the neural network, we can go to the very hypersensitivity or hypersensitivity in the ASD. Yes?
So like, I don't understand what's wrong with that thing that you called overfit. It seems like a really good fit to me.
Yeah, from the computational viewpoint, yes, it's very, very, very fitting. But the problem is that you cannot easily adapt to new situations. For example, that if some noise is coming, or if we go to the slightly different conditions, the one data moves from one place to the another, and then you have to again apply another model to explain these new situations. So such cases often happens in ASD. Because ASD people cannot easily adapt to new situations because their models are very strict. So once the environment changes, they have to renew, update their models. That's the problem in the ASD. So the tolerance is necessary, proper tolerance is necessary to adapt to new situations. Okay, so I'd like to show you our recent approaches to understand, not directly linked to the hypothesis of the prediction learning, but now we are developing the head-mount display system which can reproduce the ASD's atypical perceptions. This is a video scene which we recorded in our university campus. And now you can see the very normal images. But then once you go into the restaurants in the university, there are many people and noises. These noises and the many people movement causes high contrast and also the colorful noises in the images. And we conducted an experiment with the participant with ASD, and our analysis of their atypical perception have revealed that there are such noises, environmental noises, and also the environmental contrast causes this kind of atypical perception. Unfortunately, I don't have enough time to explain the details of this experiment and the mechanism, but I will show you, definitely show you that tomorrow in the lab visit, and also explain how we can get this atypical perception from the experiment. Just I want to give you the how, what kind of system we have in the system. So, okay, then let me conclude my talk. So I have introduced our theory based on the predictive learning, and I explained that this idea, predictive learning, can explain the diverse cognitive development and in human inference. And this idea can be extended to account for the ASD's mechanism. So by changing the tolerance for the predictive learning, we can explain the ASD's behaviors as well as the TD's behaviors. And during the first talk, I also added one more slide to answer to some questions about the consciousness and their relation to my theory. It's about the predictive learning. And I think that their consciousness has close relation to the prediction error. When we observe prediction errors, we become conscious about their event. For example, when we learn new actions, of course, there are a lot of prediction error because we don't have the predictor yet or for the model yet. For example, for the babies, the learning to walk produces a larger prediction error because they don't have the walking model yet. But once we acquire the walking actions, we don't care how we move their legs and so on. We just have a goal to go this direction or go this direction. But we don't care how to move our legs in order to walk. This is because we don't see the prediction errors in the walking behaviors. But once, for example, if you injured your legs, and if you cannot easily move your legs, you immediately recognize the prediction errors in the walking behavior. And then you will now become conscious about the walking behavior. So I suggest that our prediction learning theory can also explain what conscious is. My idea is that prediction errors has a strong relations or has a proportional relation to the consciousness. And in addition, I think that there are people with ASD we know that the people with ASDs has difficulties in creating the unconscious process. My colleagues in Tokyo University who suffers from ASD told me that she has difficulties in doing several things in parallel. Imagine that you have to go to the school and then you have to immediately prepare, like taking a shower or brushing your teeth and eating something and so on in the morning. You can unconsciously do several things in parallel. You can wearing their t-shirts or doing the brushing and so on. Some low-level actions can be done unconsciously. But my colleagues in University of Tokyo who suffers from ASD told me that she cannot make unconscious process. She has to do everything in a conscious way. That's why she often has become the panic-like behaviors, because she has to control many things in parallel.